Okay, so we have all our participants and session chairs with us. So let us begin with the session. So, hello everyone. A very good afternoon to all of you. Dear authors and all the invited guests, a very warm welcome to Technical Session 7A. Myself Yashita, and I'll be your moderator for this session. I'll make sure that things run smoothly and maybe try to keep up the energy too. So, on behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the International Conference on Technological Intelligence and Business Strategies, which is TIBS 2026, Philippines. This conference is being organized in a hybrid mode. The physical event was held yesterday in Philippines, and the virtual event is being held through Zoom on 23rd and 24th of June, where people from all over India as well as many from other countries are present with us. So I hope that you all enjoy today's insightful and knowledgeable sessions. So in the session, we will be having a total of 8 presentations. Each presenter will be given 10 minutes for presentation, followed by 2 minutes for question and answers from the chairs. I will give a gentle reminder at the 8th minute mark just to help everyone stay on track. Also, I have a small request to all the participants. Please stay connected with us till the closing remarks. We promise that it will be worth it. And if you have any kind of queries or updates, please feel free to drop them in the chat box anytime. Me and my co host will be addressing them. So, before we begin, I would like to introduce everybody to our esteemed session chairs for today. So first we have with us Professor Najera Umpar. She is an associate professor at the National University Philippines. Her work focuses on the integration of AI tools such as ChatGPT in education, digital transformation, challenges in the Philippine education system, and research on Muslim women's life experiences. Through her academic work, she contributes to advancing inclusive technology-enabled learning and foster a deep understanding of social and cultural dynamics in education. So, Najera, ma'am, welcome to the session. You would like to say something to start this session?
Yes, thank you so much, Yashita. Again, good afternoon, everyone. It's my pleasure to welcome all of you to this session of the first international conference on technological intelligence and business strategies 2026. Before we begin, I would like to extend our sincere appreciation to the organizing committee for their hard work and dedication in making this conference possible. To all our researchers, we are honored to have you here today. And yeah, we look forward to the knowledge and insights that will be presented throughout this session. So I wish everyone a meaningful and productive experience. Thank you.
Thank you so much, ma'am, for those kind words. So, up next, we have Dr. Purnachandra Rao, who is a computer science researcher, technology architect, author, and industry practitioner with over 25 years of experience in academia and industry. He currently serves as a senior solution architect and has held leadership roles at HCL Technologies, Tata Consultancy Services, Wipro, and other global organizations. His research interests include distributed systems, cloud computing, DevOps, artificial intelligence, quantum computing, and large scale data processing. So, Dr. Rao, welcome to the session. You would like to give some remarks?
Yeah, so thank you very much for giving me this opportunity, first of all. So, a couple of times, I mean, even last time also, I had this opportunity to participate here. I have seen that, okay, everybody is working on these latest technologies, trying to come to this artificial intelligence, machine learning technologies, all these things. So, I'm very much interested to go through each and every paper. I have gone through things as well, but I'm very happy that they are connected with the latest technologies. So I'm eagerly waiting to join this presentations. Thank you very much, and wish you all good luck for everyone who is going to participate here. Thank you very much.
Yes, okay. Thank you so much, sir. So let's begin with our presentations. So for our first presentation, we have with us Giri Karthik S. Are you present in the meeting, Karthik?
Yes, ma'am.
Yes, so he is here with us to present his work titled as 3P WAD, a layered three-phase framework for intelligent phishing URL detection. Also, one thing I need to tell everybody that please make this session interactive as we are connecting virtually. Everybody is welcome to ask questions to all the authors. So you can go ahead with your presentations, start sharing your screen.
Can I start now?
Yes, you can begin.
So, hello everyone. Good
You
afternoon.
have to share your screen for
Okay.
the presentation
Ma'am.
first.
Excuse me, ma'am.
Yeah.
So, is the screen visible? Okay, fine.
Yes, it is visible. You can start.
So, good afternoon or good evening to everyone. This is Giri Karthik. So, I am presenting our paper on topic 3P WAD, a layered three-phase framework for intelligent phishing URL detection, co-authored with Kalva Yamini, Kaplesri, and Ari Kishore R from the Department of Computer Science and Engineering at Sri Ramachandra Institute of Higher Education Research, Chennai. So, let me begin with a question. How many of you have received a suspicious link in the last month via WhatsApp, email, SMS, or any form of social media? Uh, it's okay, but around a minimum 1 billion phishing URLs has been transmitting every day via social media. So the scale of phishing is staggering, and the anti-phishing working group reported over 1.2 million unique phishing sites in 2023 alone. These URL accounts for 36% of all data breaches worldwide. So here's what makes it especially hard to solve. The average phishing URL lives for less than 24 hours. By the time a blacklist is updated, the attack is over. This creates three fundamental problems with existing approaches. First one, blacklist misses 0-day URLs entirely. As I mentioned before, each new URLs maximum expired by as a maximum lifetime of 1 day. Uh, when the user is reported, the URL might be vanished or it might be eradicated. So, a brand new malicious domain registered this morning won't be on any list. Second, ML classifiers face a precision recall trade-off. An aggressive model catches more threats but flags legitimate sites. A conservative model lets attacker through. And third, no single method covers all threat categories. Known threats, recently emerged threats, and such structurally novel zero-day attacks each require a fundamentally different detection strategy. This motivates us to design a layered multi-phase approach where each phase physically targets one of these categories. We present 3P WAD, three-phase verification and detection. This pipeline charts the three complement modules in sequence. Phase 1, threat intelligence lookup. We maintain an in-memory hash set of known malicious domains pulled live from three datasets such as fish tank, openfish, and URLs every 15 minutes. If a URL matches, we return a result in approximately 0.8 second to 1 second. That single phase catches 70% of all phishing URLs in our test set in under a second. And phase 2 includes multi-engine reputation analysis. URLs that pass phase 1 are submitted to the Virus Total API or multi-vendor API, which aggregates results from around 70 plus antivirus engine, including Kaspersky, Skynet, ESET, and Bitfender. We apply a configurable consensus threshold to balance false positive and negatives. This catches an additional 21% of these threats. And phase 3, final phase, CNN based zero-day detection. The remaining URLs, those unseen by any intelligence feed, are analyzed by our character level CNN model. This phase specifically targets the hardest category, structurally novel zero-day attacks. It contributes to final 9% of detection. The output for every URL is structure result, safe, suspicious, or malicious, along with the risk score and the phase that made them determination. CNN architecture. Let me go deep into the phase 3, which is the novel ML contribution of this work. The CNN take two inputs simultaneously. The first input is the domain string itself, encoded characters by character. Each character is mapped into ASCII integrated value, truncated or padded to 100 characters. This sequence passes through an embedding layer of vocab size 128, embedding dimension 32, and then through the three parallel Con1D branches with kernel size 3, 4, and 5, each with 128 filters. This parallel benches captures n-gram patterns at different granularities. Their outputs are concurrent to 384 dimensional vector. The second input is 21 and engineering domain features across 7 categories. Length-based feature, how long is a domain, character level, digital ratio, hyphen, count, entropy, Shannon entropy of the domain and subdomain. This is our stronger signal, single signal, as it will show the ablation, structural, subdomain depth, IP address in OS, suspicious TLD, keyword based action words like login, verify, secure, encoding based person encoder, sequence based base 64 like parameters, and obfuscation indicators. Lead substitution like Google G00GLE, Punicode homograms, brand impersonation in subdomains. Both branches are concatenated and passed through a 256 unit dense layer with 0.5 dropout, then a sync mode output. Why CNN over LSTM? Al-Shengindi et al., the paper we researched, shows CNN achieves 99.2% accuracy versus 96.8 for LSTM with 10 times faster inference. Given our phase 1 and phase 2 already contribute 7% of the latency, CNN 2.7 second interface keep the total pipeline under 10 seconds within browser extension usability threshold. Now the results. Phase 3 3NN CNN evaluates on our 400K URL test sets, achieve 95% accuracy approximately, 94.5% precision, 86% recall, and 90% F1 score. I want to emphasize something important about these numbers. Phase 3 only sees the hardest subset of URLs, those that are already evade both threat intelligence fed and 70% of antivirus engine. 95% accuracy on this subset is significantly stronger than its first appears. The phase breakdown on our 200K phishing subset shows the complementary nature clearly. Phase 1 handles 1,40,000 URLs at 0.8 seconds. Phase 2 catches 42,000 more at 6.2 seconds. Phase 3 captures remaining 1,800 at 2.7 seconds. Zero overlap, each phase targets a distinct category. The CNN versus LSTM comparison confirms our architecture choice. CNN achieves the highest accuracy, converge faster, and at 2.7 seconds keep our total pipeline latency under 10 seconds. LSTM estimated 4.7 inference would push us to 11.2 seconds, exceeding browser extension thresholds. To rigorously validate each design decision, we conducted an ablation study across 5 configurations. Phase 1 removal, detection stays at 100%, but weighted average latency jumped from 1.8 to 8.5 seconds, a 4.7 times increase. At an enterprise scale, the 1 lakh queries per hour, that's a 4.7 times more increase in virus total API cost. Phase 1 is cheaper insurance. Phase 2 removal detection drops from 100% to 79%. These represent 42,000 undetected URLs per 200K batch. 200,000 batch. These are extremely recently emerged malicious URL created after our phase 3 training cutoff but indexed by virus total within 24 hours to 72 hours. The CNN cannot distinguish these from benign URL based on the structure features around. Phase 2 primarily contributes coverage, not precision. And phase 3 removal, detection drops to 91%, leaving 18,000 genuine zero-day URLs completely undetected. These represent the most dangerous category. Novel attacks unseen by any feed below the virus total threshold. Phase 3 is the only mechanism capable of catching them. Feature ablation of phase 3 CNN remove. Shannon entropy features cause the largest degradation. Precision drops to 91.2%, recall to 81.3%. Entropy is the single most powerful signal for algorithmically generated and fast flex domains. Keyword feature contribute a smaller but significant plus 2.4% recall improvement for credential harvesting URLs. All 7 feature categories are retained in the full system. Beyond the code detection pipeline, we implemented 3 practical extensions. Browser extension, Chromium compatible using a mouse-up listener that activates only when a user explicitly select a URL. This is our privacy-preserving selection-based mechanism. URLs only reaching a third-party APIs when a user deliberately chooses to scan them. Results appear as an inline color-coded tooltip, green, amber, or red, without requiring navigation away from the current page. QR code and shortened URL handling. QR code are decoded via JavaScript library before scanning. Shortened URLs from bit.ly, tiny URL, and t.co are resolved via HEAD request to reveal the true destination. before analysis. We tested
Sorry to
3,000.
interrupt, Karthik. Just a little reminder. You have to wrap up within 1 minute because
Sure,
it's
ma'am.
already, yes.
Okay, ma'am. And final one, microservice deployment. Each phase is independent, deployable, and scalable. Phase 3 workers are GPU accelerated. Redis caching at the API gateways server, repeated URL lookups within a 6-hour window, substantially reducing virus total API consumption enterprise environments. On privacy, these systems process only the URL string itself. No page content, DOM elements, cookies, or credentials are accessed. So let's conclude this presentation. To summarize our contributions, 3PY demonstrate that no single detection mechanism can simultaneously achieve adequate coverage, low latency, and zero degeneralization. By chaining threat index lookup, virus total consensus, and CNN-based structure classification, we achieved 100% combination detection across all three categories, within 70% resolved under 1 second by phase 1 alone. Our ablation study confirms that all three phases are non-redundant, each has a distinct role that cannot be replaced by each other. Phase 3 3NN achieves 95% accuracy on the order 0-day subset and a strict latency constraint that is made suitable for real-time browser use. The framework is privacy preserving by construction, GDR complement, and practically validated to browsing extension integration, QR decoding, and microservice deployment. Future service include CNN random forest ensemble to improve recall, asynchronous phase 2 scoring to reduce perceived latency, whose domain age features, adversarial robustness evaluation, and formal bias auditing across geographical and linguistic etc. Data. Thank you, and I'm happy to take questions.
Yeah. So thanks for giving me this explanation. It's excellent framework, I can tell you. But the point here is you said that in the first phase to second phase, you made it to 70% reduction or something like that. What is that you have done it in the second phase to find out that phishing things? You said 70% you have achieved something like that. What is the technique? Can you please repeat it again?
Sir, can you repeat the question again?
The three phase framework, right? The first
Yes,
phase
sir.
to second phase to third phase. So third phase you have done something with this machine learning, something like that. The
Sir,
second phase you was
actually, the first phase includes real-time database data. We received the data from URLs from real-time database, such as URL fish tank, OpenFish, and AbuseCH. We check from that, and we kept our data as a Redis cache or local database. So we compare with them for faster data sets. Sir. So in the
Mm,
missing URL, from the missing URL, I mean,
my question is different. I think so. Sorry, let me repeat it again. In the
okay, sir.
second phase, at the end of the second phase, you are carrying with some data to the third phase, right?
Yes, sir.
So that time itself, did you achieve something in the second phase?
Sir, reaching, I mean, I can't, I'm sorry, sir, but I can't understand the question properly.
Go to the first side or second side and show
Okay,
me.
sir. Sure,
Yeah.
sir. Is this one, sir?
No. It's not updated. Still, I'm seeing conclusion. Yeah, come back. Go to the next one. This one. Yeah, phase one, phase two. Phase two, what you have done here? Multi-engine analysis. What you have done here?
Sir, actually, we called upon an external service such as Virus Total or Google Safe
That's what
Browser
I'm
Engine.
asking. You have detected 21% something here. What is the technology you have used here? This is what I was asking you.
Sir, that's what, sir. We used, for the first one, we used a real-time database. For the second
Okay.
one, we used APIs, multi-vendor APIs, such as Virus Total or we passed the data to Virus Total API or to
Okay.
Google Safe
Got it.
Browsing API.
It's okay. Got it. See the last slide is somewhere else. Last but one slide you have mentioned Redis cache.
So,
Go back.
sir, for Redis cache is what we used for us.
Hold on.
Uh, actually, we use Redis
Hold
cache.
on. I didn't
Okay,
finish my question. Okay. Last but
sorry,
one
sir.
slide, you have mentioned Redis cache. Go back to that statement and show me something 6 hours or something. Show me that one.
6 hours.
Not here after this one, I think. Yes, here. See, Redis cache 6 hours TTL reduces VD. Can you please complete this statement grammatically? What does that mean?
Sir,
What does it mean?
so for each time a user uses the extra browser extension or
Yeah.
device for repeated scanning of URL. For example, in a website, for example, if I take an
No. That's okay. Cache meaning is that one. That's Don't define the cache process here. Try
Okay,
to
sir.
try to give that explanation of 6-hour TTL reduces VTAPI
Sir,
calls. Complete that session.
actually, we don't scan multiple if we scan a multiple same URLs once, each time we scan a same URL, virus total consumes more amount of URL. For example, virus total has only 4 URL scanning limit per minute on free trial, and for a day only 15,000 URLs per day, sir. By using reduce cache here, we can reduce the same URL reduction, sir. For example, if I scan the same URL, if I scan the URL to the same one here, and if
No,
I
no, no,
scan,
no. You are trying to explain about the cache. Leave it about the cache. So now point is, what is the 6-hour TTL reduces VT API calls? Explain only the terminology to me. Don't give an explanation of cache. Cache is different. Okay. What is that 6-hour TTL reduces VT API calls? Just explain the terminology. Are you getting me? No.
yes, sir, I'm getting, sir, but
Tell me. Tell
uh,
me.
that's what I'm trying to explain, sir. AP without cache for 100 users for 100 virtual
I
requests, sir.
agree with
But
you. I agree. What is 6-hour TTL means here? What is TTL?
sir,
What is
sir,
TTL here?
TTL.
TTL.
Oh, okay, sir. For sir,
I'm
for your
asking the
TTL full
terminology
form is
only.
time to live, sir. For example, how
Okay.
long should it should
Okay, time
take?
to live. Okay. Then 6-hour time to live reduces. VT API calls means reduces two or something. I think that's what it's not
Sir,
fulfill.
VT means virus total AP. I mean,
Okay, API call 6-hour TTL reduces VPD. I don't think it is fulfilling the entire statement. It's okay. You can look back it later. Okay, once we are done with it. It's okay. I'm done with my questions. Okay.
Okay, Najera ma'am, do you have any questions for him?
Thank you so much. Thank you, sir, for your presentation. It was well organized, informative, and clearly presented. At this point, I don't have any further questions, but I really appreciate the valuable contribution of your research. Thank you.
so much thank you for your response, ma'am. So much thank you for response also, sir.
Thank you so much, Karthik, for presenting. So next up we have Farai Jonha to present her paper titled as a systematic review of deep autoencoder and HDB scan clustering for explainable consumer segmentation in the banking sector. So Farai, are you present?
Yes, I am.
Yes. So are you ready with the presentation?
Yes, let me.
Yes, you can
Someone
share.
else is
Yes, yes.
someone else is sharing. Can you now see my slide, my
Yes.
screen?
Yes. Yes.
You can?
Yes.
All right. So, greetings. My name is Farai Jonah, and I'm from the Harare Institute of Technology, Zimbabwe. And this work is
Rai, can you
co-authored
put your
by.
slides on presentation mode, please?
Oh, all right. Is it okay now?
You can go.
All right. So this work was co-authored by Engineer Mtandawari and Engineer Ndlovu from the computer science and data science analytics. So the title of my project of my study was a systematic review of deep autoencoder and HDB scan clustering for explainable customer segmentation in the banking sector. The study proposes the explainable customer segmentation framework, which integrates deep representation learning, density-based clustering, explainability, and governance mechanisms to support customer segmentation in regulated banking environments. The problem statement. So I've realized that traditional customer segmentation in banking, especially in Zimbabwe, relies heavily on methods such as K-means. However, modern banking data is highly complex, nonlinear, and characterized by diverse customer behaviors. So conventional clustering methods often fail to identify minority, But important customer groups, including dormant customers, early chainers, and high-value customers, early chainers and high-value customers. Furthermore, most existing approach lack explainability and governance mechanisms required in regulated environments. So the gap identified in literature, the literature reviews several limitations. Central-based methods struggle with irregular cluster structures, while linear dimensionality reduction techniques fail to preserve nonlinear relationships. Deep clustering methods improve representation learning, but often lack interpretability. Similarly, HDB scan effectively handles noise and arbitrary cluster shapes, but few studies integrate it with deep learning and explainability. So overall, fewer than 26% of reviewed studies combine deep representation, learning, density-based clustering, and explainability in one deployable framework. The research questions. This review was guided by 4 research questions. First, we examined how deep learning methods for customer segmentation evolved between 2017 and 2025. Second, we compared density-based clustering approaches with traditional methods. Third, we investigated the adoption of explainability techniques such as SHARP and LIME. Finally, we identified the challenges limiting deployment in regulated banking environments. Framework component 1, which is the multitask deep autoencoder. The first component of the explainable customer segmentation framework is the multitask deep autoencoder. It learns compact latent representations while simultaneously considering segmentation, chain prediction, and credit risk task. This approach captures meaningful behavioral patterns and improves the quality of downstream clustering. Component 2 is the HDB scan clustering and stability. The second component, unlike K-means, HDB scan automatically determines the number of clusters and effectively handles irregular cluster shapes and noise. Cluster robustness is assessed through bootstrap, resampling, and temporal stability analysis to ensure consistent customer segmentation over time. Then the component 3, which is the SHARP explainability, the SHARP layer and benchmarking. An XBoost surrogate model combined with SHARP values explain why customers belong to a particular segment. This provides both global and customer level explanations, thereby enhancing transparency and supporting regulatory requirements. Assess strategy and study selection. The review followed the PRISMA 2020 methodology. So a total of 630 studies were retrieved from 6 databases covering the period from 2017 to 2025. Following duplicate removal and screening, 71 studies were retrained. Inter-reviewer agreement was strong with core and kappa value of 0.81. Inclusion-exclusion criteria. Only original empirical studies in banking and financial services were included. Non-English studies or review papers and studies without segmentation tasks were excluded. This ensured that the review focused specifically on machine learning-based customer segmentation in banking. Evaluation metrics across the corpus. The findings indicate that silhouette score was the most widely reported metric. However, stability metrics, external validation, and temporal evaluations were really considered. In addition, deep autoencoder and HDB scan became increasingly popular over time, reflecting the transition from conventional clustering approaches. Three critical gaps. Three major gaps emerged from review. First, explainability was incorporated in fewer than 26% of studies. Second, less than 15% performed external validation. Third, temporal stability testing appeared in fewer than 9% of studies. These limitations hinder practical implementation in real banking environment. Comparative overview of clustering methods. The
Sarai,
review
sorry
shows.
to interrupt, but you'll have to wrap up within 2 minutes because it's
All right.
8 minutes already. Yes.
All right. The review shows that deep clustering approaches dominate current research with HDB scan becoming increasingly popular because of its flexibility and resistance to noise. Meanwhile, the use of K-means has steadily declined, demonstrating the shift towards more advanced clustering. Most studies originate from the United States, China, and Europe. Less than 10% of studies come from low and middle-income countries like Zimbabwe. Furthermore, the majority of studies were conducted with academia, with limited participation from banks. Future research directions based on the identified gaps. Future work should focus on temporal clustering fairness, awareness, aware approaches, federated learning, and self-supervised learning, explainability, and regulatory obligations. Imagine regulations such as GDPR, Basel III, and the EUI Act emphasize transparent and accountability in artificial intelligence system. However, many studies demonstrated high risk in explainability and reproducibility and data set transparency, highlighting the need for government-oriented frameworks. Quality assessment reviewed that clustering demonstrated good implementation quality. However, explainability and reproducibility remained the weakest domains, with more than half of the studies exhibiting a high risk in explainability. So to address these limitations, we propose the explainable customer segmentation framework, which integrates 8 components: a multi-task encoder, HDB scan, instability assessment, sharp explainability, drift monitoring, bias and fairness monitoring. Together, these components provide a deployable and governance-ready architecture for customer segmentation in banking. The proposed explainable customer segmentation framework supports model governments through explainability shift, drift monitoring, fairness assessment, and lineage tracking. These capabilities align with SRR 11.7 guidance and GDPR requirements, thereby promoting transparency and accountability trust. In conclusion, deep autoencoders combined with HDB scan represent the state of the art for customer segmentation in heterogeneous banking data. However, explainability, external validation, and temporal stability remain significant challenges. So the proposed explainable customer segmentation addresses these gaps by integrating clustering, explainability, and governance into a unified architecture. Ultimately, this work viable customer analytics in regulated banking environments. I'll say thank you.
Okay, so you have mentioned that a couple of pages of data records collection till the final corpus preparation, right? So inside that removal of duplicates, a couple of pages are there. So what is that framework you have used? I mean, did you use any language here? Or what is that you have used to accommodate this framework?
Sorry, I can't hear you clearly.
See, if I mention that number of stages, right, from collection of the records till the preparation of final corpus. Okay, so here removal of duplicates and couple of stages you have mentioned it. So all this framework, where did you accommodate it? Did you use any programming language?
Yes,
What is that?
Python.
Okay,
Python.
how did you
I'm
remove the
currently doing the project.
how did you remove the duplicates?
Sorry. How did I remove the duplicates?
Yes. What is the process you have using?
The data set. For cleaning, I used was my data set had some had no there were
Okay.
no
Okay, fine. Okay, fine. Then one more
sorry.
point. Have you ever faced this filling the files? I mean, while entering the data, there should be some gaps in the data, so the data is not available. How did you fill
Yes, we
missing
did
data?
some good
How did you fill the missing data?
imputation.
Okay, good,
Imputation. I used imputation.
good. No problem.
Yes.
Yeah, I'm done. I'm done. Thank you.
Modern mean okay, it's fine.
Okay. Najera ma'am, do you have any questions? Or should we move forward?
Thank you so much. First of all, thank you for your presentation, ma'am. Yeah, it was very interesting and well presented, Steady. I don't have any question at this time, but I really appreciate the significance of your research and its contribution to the field. Thank you and congratulations.
Thank you.
Thank you, ma'am.
Okay, so for our next presenter, we have Muhammad Suleiman. Are you present, Muhammad?
Yes, ma'am.
Yes, so he is with us to present his paper titled as AV Shield, a hybrid machine learning framework for real-time, low false positive credential leakage detection in enterprise DevSecOps. Okay, so you can start presenting. I must say it is a very interesting topic. You can continue.
Yes, ma'am. Thank you, ma'am. Hello. It's good morning and good afternoon to everyone. Myself, Mohammed Suleiman. I am Tech CS student from BMS College of Engineering, and my co-authors are Srivatsa and Kavita ma'am and Revant and Danush. So, basically, my title is AV Shield, a hybrid ML framework for real-time, low false positive credential leakage detection in enterprises DevOps security operations. So basically, this ideology came from I had taken from an problem statement like GitHub. Okay, like GitHubs are exposed rarely. Whenever we commit the data or anything that stores in a commitment configuration files. So whenever we are pushing some data, every record, a file modification related, everything will be stored. So whenever we are inserting our API keys in the file systems, like configuration files for importing that, so API keys will be exposed in the commitment statements. After it, nowadays GitHub is exposing their partnered API keys will be notified in the emails, but maximum API keys will not be exposed by GitHub to aware the user regarding that. So my framework will help it, and mainly why I choose the GitHub. Millions of testing or all the data sets or anything which are publicly available are pushed in GitHub or GitLabs. So in that, defaultly it is like Git leaks and Toggle Hawk, which is like uh, helpful for whenever we push the data or anything. Any Git APIs are explored, we can be detected using that, but still it will give a false positive data. Means the data has been not exposed with some keys may left over which are not recognizable. So my AV Shield stands for an automated vulnerability scanning hybrid implementing integrated leakage detection. So what it does is like it is a hybrid model, which is credential detection. We have used a regular expression for pattern matching for each classifier. Each API keys will be represented. We know that GitHub pattern find gain APIs are stats with the git pat. So we can recognize that some APIs keys has some keywords. So based on that, we have written a regular expressions, and some are which are not recognizable. We have written a generalized generic pattern recognition, and which we are going to be trained with the model like random forest. So random forest which helps to train the model without overfitting it. And other models we can't specify, as we can't give the risk scores. But ML random forest give us the exact the probabilistic ML score for risk calculation. We use that. And literature survey which I did is like git leaks repo scans workspace scan is not available in git leaks. After it is pushed, then it will going to be detected. And toggle false also, there is a no containerization like dockers. But my model what I does is like in the docker itself we are going to use a watchdog which will help us to monitor that every 3 seconds any modification in the file happens. Is that file contains any API keys, hard-coded API keys developed by the developer, and it will be immediately notified to the developer that your key is present in this particular line, and etc. So basically, our system architecture like developer workspace, that is Docker space, and GitHub repo, like shallow cloning. Like already our GitHub is there, and GitHub repo we can replicate it. And in that GitHub repo, I have restricted to 100 MB because I was using AWS free tier, so I unable to extend the storage of it. So whenever it is shallow clone, it will scan complete repo, and it will give already exposed API keys whichever present in that particular directories. And whichever not there also, that will be also identified and can be given to that particular already pushed data. So we can realistic data we will get to know. And if it is not export, we can modify and store it in the secret management systems. And another is real-time monitoring, which is like our workspace will be monitored continuously for our anything that is like pattern matching. Any API keys will be exported in any extension. Example, some files like XYZ file has the API keys of our files, and it will be exposed if we push the data. Means only configuration files will not be having. Another files also can be used for intermediate for API calls. So pattern kind of matching and AI detection model is there, and risk analysis model. After everything, if anything we find that API keys has been exposure, so alert manager will going to alert. In that also we have specified that already exposed key has been identified, that mail will be not be sent again. Once it will be sent, another reduplication will not be happening. So uh, okay, like feature extraction importance with that, like length and entropy, that is shallow entropy we are using. And how much it is contributing, that percentage we have defined here, that is specific ratio 0.4, that is more important. Special ratios, and length and upper ratio, and entropy and digit ratio. And basically these are the features which are used for vectors. And for regression expression, we has used AWS, GitHub, Azure, and Stripstat, and some more APIs which are commonly shown. Like another, and we already explained regarding this. So, okay, and as I am using synthetic data, so obviously the precision recall scores are accurate like one, and our model gives accurate results. And risk score like baseline model score, and the ML score which has been given, and business multiplier always will be 3. And this all the things will be multiplied, and we get the like scores. The scores indicates that threshold value which can be given for high risk, low risk, and everything. and reduplication, like every time the mail is going. So instead of spamming it, whenever we are using a SHA-256 fingerprint, which is like file path line number, whichever line is there, and the one secret text that will be attached for an unique identification for not reduplicating the notification. So whichever for workspace monitoring, I told like watchdog library, which is a Python inbuilt library, and Streamlit app we are using for the dashboard, whichever it was refreshes every time. And for the thing is like automatic the report generation, we have used report lab, everything. Experimental things what we have done is 10,000 lines of code was containing, and in that we were like 50 like we have inserted 50 real secret keys, and we tested to our model almost like a pure regression scanner like GitHub has exposed that all 50s are original, but in that 50 was not real. But what the thing is like 49 was real, and the 2 was false positive. And what the existing model gave is 47 was false positive, which was a precision score was false. And our precision score reduces that false alert was 90%, 95% was reduced. And this was the testing which I done, I git scan which did, and it identified how many leak has been happened in our already pushed data. So it will give one, or that was like traditional model also gives that everything whichever it sees that it is an API key, that or everything it is not an API key also, it will be detecting as API keys, traditional models. But our model what does, whenever the accurate API keys was exposed, that will be identified and the line numbers will be given. I use, as you can see, that which line and what API keys has been identified. And for reduplication, I told that SHA-256 we are routing for stopping the notification for like not making it a spam. And system MD, it is a file which going to run my API calls, and my Streamlit to be running backgroundly for watching continuous monitoring for the workspace. And email notification, you can see that like 1 minute. And AV Shield as an identify that workspace 2.5, like a Python file which is 2.py. It can also be having a secret key, but I tested that it identifies irrespective of the configuration file or normal file also can contain. It is scanning that the API keys has been exposed, and it generated a PDF file which can be attached with that email. So conclusions that it is giving an high accuracy, but the thing is like we should test the real time data, whichever which is like bug bounting can be helpful for us to integrate it. Still we don't going on research to extend this knowledge and integrate the latest technology for more contribution. Thank you.
Okay, so you have mentioned like in GitHub commits or in the workspace, if someone is going to keep that hard coding the credentials, then you are going to find out that where it is appearing. This is what your aim, right? If
Yes,
I
sir. Before the pushing the data, we are going to identify and safeguard it. That is our
no,
aim.
not pushing. The developer is going to push the data to the GitHub commit, Git only. Then only you are going to work on that one, right? What do you mean you're pushing here? Where you are going to push?
Yeah. So like what the thing is, workspace will be the default thing. Like we have a workspace. In that workspace, everything the project developer uses, everything it will be done. After that, he use CI/CD pipeline to push the data to GitHub. Okay.
No, no,
So
hold on.
mm,
CI/CD pipeline to push the data GitHub. No, no.
mm,
Developer has to do everything in his laptop, in his workspace. Then that guy needs to push the data into the GitHub. Then
yeah,
that
yeah.
CI/CD will come into the picture. Okay, okay. Leave
Uh,
that process. Now you tell me what
okay.
is that you are doing here. So someone has hard coded the credentials into the file. That's what you are telling. Assumption, right?
Yes. Yes.
Then what is that you are going to do here?
Before the pushing of the data, our what the we are another before pushing the data, the workspace to be scanned by the monitoring tool, which I told is Watchdog.
For
Watchdog
what,
has a
for what it is going to be monitored? It's going to monitor.
API keys, whichever API keys which is been already in her file,
It's
whichever
hard
file.
coded. Hard coded. That's what you mean, right? Hard
Yeah,
coded.
yeah, yes, hard coded.
See, actually, that's okay, fine. Anyhow, you worked on something. I'm not discouraging. No one
Yeah,
is doing that one actually. That is a good program. It has fundamental route to develop the fundamental principle to work on the development environment. They
yeah,
should not keep any credentials or anything. They should not hard code anything in the code workspace. That eventually workspace will go and sit on the GitHub. Okay,
yeah,
no one is going to do that one. Okay,
yeah,
that's okay, fine. You have done something. I'm not discouraging. Fine, leave it.
yeah,
Okay, coming to the next point. So whenever one developer is going to commit the code into his GitHub branch, he
yeah,
needs to make sure that he has to decentralize. He needs to use layers mechanism so that he's going to use placeholders of the credentials so that that guy needs to connect with the vault or some other locations. That's different story. Okay.
yeah,
So that's fine. Now coming to the point, you said that some watchdog or something. You said that you are going to keep inside the Docker container. What
yeah.
is that? Why are you keeping inside Docker container?
Docker container means that the code will be updating by the developers. The developer code updates whenever a API keys will be inserted in the any particular file. That will be
Okay.
exposed and identified to not to keep the files like not to
No,
expose
no,
the
no. That is what
API.
we discussed. Again,
Okay,
the new guy came into the picture, Docker container. So far, we discussed about workspace, GitHub,
that
and your
workspace
team.
is called Docker, sir. I have created that workspace as a Docker. Why? Because we keep all our configuration, our environmental files there. So
Docker. No, it's okay. You try to revise it and update because Docker is different tool totally. Okay. It is giving, it's misguiding, it's misleading to some other tool. Fine. Okay. You go back and check it again. Docker is totally different. Workspace is different. GitHub is different. Developers playing with the workspace, then they are going to push the data into GitHub.
yes,
Okay,
sir.
that too,
But
whatever you have mentioned the logic, and that's not going to work out also because no one is hard coding the credentials. That's not allowed policy principles. While there is a fundamental principle while you are developing the code. It's okay. I'm done with my questions. Okay.
okay, thank you, sir.
Okay, Najera ma'am, do you have any questions for him?
Thank you, ma'am. For the presenter, thank you for the insightful presentation. The topic is actually relevant and timely, and the findings were presented clearly. I don't have any further questions. Congratulations on your work.
Thank you, ma'am.
Okay, so for our next presentation, we have Alfred Edinsi, who is here to present his work titled as Detection and Treatment of Rice Diseases in Benin using AI, a systematic review. Alfred, are you with us?
Yes, hi everyone. Do you hear me?
Yes, you can start your presentation.
Okay. Okay. Do you see my presentation?
Yes, it is visible. You can start.
Okay. Good morning, everyone. My name is Alfred Adensi, and I'm a researcher at the University of Calavi in Benin, West Africa. Today, I'm presenting a systematic review entitled Detection and Treatment of Rice Disease in Benin using artificial intelligence. This work was conducted together with my colleague Elijah Wenge. There are too many surveys on AI for plant disease detection, but almost none of them ask a very simple question. Does this solution actually work in a place like Benin? That is exactly the question we set out to answer. We reviewed 220 studies selected from 319 Scopus publications covering the period 2019 to 2025. Here is our plan for the next minute. We will start with the motivation and the research clip. Then we will describe our methodology. We will then present our results and the disease landscape and on AI performance. We will assess how applicable these results are to Benin, and we will close with our priority recommendations and a concrete deployment roadmap. Rice is not just a crop. In Benin, it supports 2 million people and employs roughly 70% on the rural workforce. Globally, rice feeds 3.5 billion people, and yet the Food and Agriculture Organization estimate that pest and pathogens destroy to 40% of food crops every year. The three most damaging diseases in our context are rice blast, brown spot, and bacterial leaf blights. Rice blast alone can cause yield losses of 10 to 30% per season in our country where farmers have little margin or error. Now AI-based detection has made real progress. CNN, Vision Transformer, and hybrid architecture are achieving accuracy rates above 94%. But here is the problem. When we reviewed the existing survey, we found out that they benchmark models against each other without ever asking, can this run on a low-end smartphone? Can it work without internet? Has it been tested with West African farmers? Only 4.1% of studies in our corpus come from Africa, and the American varieties, which are the main cultivars grown in Benin, are absent from virtually all reviewed datasets. So our research question is this, and it's visible at the bottom of the slide. Which AI techniques for rice disease detection are both effective and deployed in the Benin context? That is what we answer. Our methodology follows the trademark guideline. As you can see in the table, we start with 319 publications from Scopus. After removing duplicate and screening and title and the abstract, we reached 367 articles. Then we conducted a full test quality assessment. Each paper was scored on a 10-point scale covering methodologies, producibility, data quality, and their potential impact. Only papers scoring 6 out of 10 or above were retained. This brought us to a final corpus of 220. At the bottom of the slide, you can see our PICO framework. Our population is rice crop affected by disease. Our intervention is AI, deep learning, machine learning, and hybrid method. Our comparison is cross-family benchmarking, and our outcome is a combination of detection accuracy and practical applicability. Let's look at what the literature covers. The charts on the left show the distribution of studies by disease. That's blast community. That is 70.9% of the corpus. Transport follow and bacterial lab at 44.5%. These three diseases are not chosen arbitrarily. There are precisely the diseases that matter most in Benin's tropical landscape. Now look at the observation curve on the right. 85% of studies were conducted in tropical climates, temperature between 25 and 35 degrees Celsius, humidity between 70 and 90%, which match Benin conditions. That is good news, but here is the issue. Only 4.1% of the studies come from Africa countries. And when we look at the datasets used, none of them include the America varieties grown by Beninese farmers. So the climate match is here, but the local relevance is not. The table of the top compares the three main families. Deep learning accounts for 64.5% of studies and achieved a mean accuracy of 94.2%. However, most deep learning models require a GPU to run. In a country like Benin, where extension agents use large-range smartphones in a field that is a hard concern, hybrid approaches, meaning combination of deep learning and classical machine learning, accounts for 21.8% of studies. They achieve a hard first link accuracy. It's 95.8%, and critically 73% of hybrid models are compatible with versus limited hardware. Classical model learning represents 13.6% of the study. Strict sub-precision and interpretability, low compatibility cost, and robustness on small datasets, all which matter when farmer adoption, which depends on being able to trust and explain the model output. In the two smaller table below, you can see the top performing model in each category. I want to draw your attention in a few. Mobile net plus SVM in the hybrid table, 89.4% accuracy, compatible with the main config. In the yellow V8 in the deep learning table, real-time detection at 45 frames per second. The slide puts geography bias in perspective. South Asia accounts for 44.5% of studies. South Asia, mainly India and Bangladesh, for 30.5%, China for 12.7%, Europe and North America together for 8.2%, and Africa studies 4.1%. On the right, we can see the data source. Priority data source dominates at 30.5%. Table and the plant village together represent another 20 to 33%. Local contextualized collection. The kind that will actually reflect the Benin's field condition. It accounts for just 7.3% of the corpus. We have developed standardized collection protocol targeting the four main Beninese rice-growing basins, covering lyrical variety at 500 to 1,000 images per disease classes, in partnership with INRAB and local structure. Let me now be specific about what works and what doesn't work for Benin. The transferability table tells a clear story. Climate compatibility is excellent at 85%. Dataset accessibility is reasonable, with 89% of models supporting transfer learning, but hardware adaptability Only 30.5% of studies propose solutions running on limited hardware, under 100 megabytes, under 2 gigabytes of RAM. That is reducing. Below the table, I want to highlight three barriers, and that barrier appear in the literature that determine almost everything in practice. The first is digital literacy. Only 3%, only 23% of solutions include simplified and or multi-language interface. The second is connectivity. Rural Benin operates on intermittent 2 gigabyte and 3G coverage. Offline capable solutions are not a preference, they are a requirement. The third is institutional and adoption. Further, the main agricultural extension
Alfred,
service.
just a quick reminder that you have to wrap up within 1 minute, okay?
Okay.
Yeah.
Service in Benin has no framework for AI diagnostic tool. This means and deploy require urgent training, clear protocol, and political support and at the ministry. The table is the core contribution of the review. We evaluate each approach of two dimensions simultaneously, technical performance and applicability under the main infrastructure constraints. Let me walk through it. ResNet plus UTH 96% accuracy. MobileNet plus SBM reached 89.5%, and the key inside is at the bottom of the slide, and I want to read it clearly. Performance alone is not the right criterion, but the 96.4% of ResNet is relevant if the model cannot run on the beginner's farmer's smartphone. Okay, to the deployment, we have three phases. Phase 1, 0 to 12 months, deploy MobileNet plus SPM full cable extension agents. Phase 2, 12 or 24 months, rollout optimization Euro V8, and Phase 3, local datasets will be available. The target is 500 to 1,000 images per disease classes. Let me close with the conclusion. First, hybrid AI approach at 95.8% mean accuracy outperform both pure deep learning and classical machine learning. Second, the three diseases dominated the literature: gas blast, transport gas, bacterial blast, match exactly the theory of the new tropical gas disease. Third, and this is perhaps the most important thing, the gap between what we have built and yet what can be deployed in the new is not primarily a technical gap. Fourth, three priority solutions address different deployment horizontally within our infrastructure constraints. Future work will focus on local dataset contribution through in-lab partnership, usability research with farming communities, and ethical farmers, a framework covering data ownership and responsible communication of model accuracy. The scientific foundation for AI-assisted RAS disease detection in learning is solid. What remains is the harder work of making it useful. Thank you. I welcome your questions.
Yeah. So it seems like you have taken the data from different data sources, right?
Yes.
So what is that procedure you follow? Did you use any extraction tool or transform load, something like that?
Yes, we get some data from Scopus, and also we use a R Studio to enable it to extract data set and to to get the duplication and the bias in it.
Okay. Okay, fine. I'm done with my questions.
Okay, do
Hello?
anyone else have any questions for him? Najira ma'am?
Yes. Thank you so much, ma'am. First of all, thank you for your presentation, sir. I have one question. Based on your review, what are the main limitations of the current AI application in rice disease and treatment, particularly in the context of Benin?
The concept is the application and also the technical capability to partners to use technical elements. So we face this, but we are also we have also a problem with the data set collection because we have not at this present at this moment the data set to train our model. So we are trying to get some data set from the fleets in our basin in the country. That's the problem we face.
All right. Thank you so much. I think that's all for me. Thank you.
Thank you.
Okay, thank you so much, Alfred, for presenting your work. So up next we have with us Gusti Ayo Agung Devi Suchitawati Pinati. Are you here with us, ma'am?
Yes, I'm here, ma'am.
Yes. So she is with us to present her paper titled as From Tradition to Transformation, Digital Public Service Innovation and Sustainable Governance in Bali. So are you ready with the presentation?
Yes, but
Yes.
okay,
Yeah, you can share now.
okay, already. It can be seen, ma'am.
Yes, it is visible. Just put it in the slideshow mode and then
Okay, okay.
yes.
Good evening, all. I am Igusti Ayu Agung Dewi Sucitawati Minati. I'm from Universitas Pendidikan Nasional Bali, Indonesia, and my friends Jonathan Jacob Paul Latu Perisa from the Philippine Women's University, Manila, Philippines. Today, I will present my paper called From Tradition to Transformation, Digital Public Service Innovation and Sustainable Governance in Bali. The background of the research. Across the globe, digital transformation has emerged as a central strategy for improving the efficiency, transparency, and accessibility for public services. Government at every level are investing in technology-driven solutions to modernize service delivery, reduce bureaucratic friction, and enhance citizen engagement. Yet, a critical insight shapes this review. Technology alone is insufficient for achieving sustainable public service delivery. Lasting transformation requires more than digital infrastructure. It demands aligned governance structure, institutional readiness, and a commitment to long-term public value, particularly in subnational contexts where local cultures need to be stressing. The research gap, what existing studies cover, a substantial body of literature addresses digital governance, e-government adoption, sustainability frameworks, and public sector innovation, but largely in isolation. Scholars need to treat technology, governance, and sustainability as a separate analytical domains. And what remain understudied, very few studies integrate all three dimensions simultaneously, and fewer still do so in a subnational context as Bali. This fragmentation leaves a critical gap, the lack of integrative framework that reflects the complex, interdependent nature of sustainable digital governance at the regional level or local level. The third question, how does the existing literature explain the relationship between sustainability, governance, and digital innovation in public service delivery? What conceptual frameworks and empirical findings emerge from reviewed studies? And the second one, integration in Bali. How are these three dimensions, technology, governance, and sustainability, currently integrated within Bali's regional digital governance landscape? What local practices and programs reflect or differ from the international literature? Research method, the study employs a systematic lateral review, rigorous and reproducible methodology from synthesizing scholarly evidence. The essay follows a structured 5 phases process designed to ensure transparency, minimize selection bias, and pursue analytically robust finding applicable to both theory and policy. So the first step is determine the keywords, identify search terms and synonyms, and then database, validate sources, and then abstract, validate sources and coverage, and the abstract, screen for relevant and fit, and full text, analyze methods and findings. Keyword validations. To ensure comprehensive coverage of research domain, 3 core keywords cluster were identified and validated through iterative database searches across Scopus. First one, e-government, digital platform, electronic service delivery by public institutions. Public service, it means government provides services and citizen-facing administrative function. And sustainability, long-term viability, equity, and environmental responsibility in governance. And the Prisma process. The study followed the Prisma preferred reporting item for systematic literature reviews framework to ensure methodological rigor and transparency in study selection. Records were progressively filtered through eligibility and relevance criteria. 62 initial records retrieved from academic database using validated keywords combinations, and 48 after screening, remaining after title and abstract review for relevance and scope. And then 22 eligible studies will take articles meeting all inclusion criteria for all quality and topical fit. And 22 included studies final courting for thematic analysis and synthesis. And this is the process of the Prisma selection from 62 article to 62 article. The first step is identification, 60 document retrieved from Scopus using 4 keywords. And the second step is elimination. Elimination duplicates, ineligible tiers, and missing abstract also removed. And the third step is screening. Screening 48 documents screen, 5 articles excluded, and leaving 43 articles. And the fourth one is inclusion. 22 studies access for eligibility and fully included. So for the thematic category, is the first is dimension. One is technology. Technology dimension encompasses digital tools and infrastructure that government employ to modernize service delivery. Reviewed literature highlights 5 dominant technological paradigms shaping contemporary e-governance. And from the article, it can be concluded that e-government and digital platform. It explained centralized portal enabling citizens access to administrative service online. Also talk about blockchain, decentralized ledgers, enhancing data integrity and anti-corruption measures. And also talk about IoT and smart cities, connected infrastructure, improving urban service management and responsiveness. Dimension 2, governance. Effective digital transformation is inseparable from the quality of governance structure that surround it. The literature consistently identifies 5 interconnected governance factors as critical or humanitarian sustainable public service innovation. It can be concluded that first one, institutional capacity, technical skill, regulatory frameworks, organizational readiness to implement and manage digital system. And the second, participation, inclusive mechanism that engage citizens in co-designing and evaluating public service. And the third is public trust, citizen confidence in government institution and digital platform as a prerequisite for adoption and use. The fourth one, leadership and collaboration, political will, and cross-sectoral partnership that sustain reform momentum across administrative cycles. Dimension 3, sustainability. Sustainability dimension moves beyond environmental concern to encompass the long-term viability, and social legitimacy of digital governance for public service to be truly sustainable. It must endure across political cycles, serve our population segment equitably, and deliver lasting social value. So the key point is long-term continuity, system resilient to political transition and budget fluctuations, inclusion and equity, services that reach marginalized and rural communities, and the third, environmental responsibility, minimize the ecological footprint for digital infrastructure. So this indexing model, the review central theoretical conclusion, is a tripartite CITES model, asserting that successful and sustainable transformation cannot occur when any single dimension is addressed in isolation. Technology without governance produces fragile system. Governance without sustainability loses public legitimacy. Sustainability without technology lacks delivery capacity. So in the Bali context, cultural foundations, Bali offer a distinctive case study in which centuries-old philosophical and institutional framework provide a ready foundation for sustainable digital governance. Two cultural pillars that set out as particularly relevant. The first one is Trita Karana. Karena it's local genius, local values, Balinese Hindu philosophy, emphasizing harmony among three relationship: human to God, human to nature. This worldview naturally aligns with the sustainability and inclusion values embedded in contemporary digital governance framework. And also, Trihita Karana can be example in Subak system. Subak system is already a UNESCO heritage, recognized traditional irrigation cooperative system that has governed Bali rice paddies for over a millennium. Subak demonstrate that collaborative participatory resource governance principle directly relevant to open and equitable digital service design is deeply embedded in Balinese institutional culture. So another
Sorry to
example.
interrupt. Just a quick reminder, you'll have to wrap up within 1 to 2 minutes. Yeah.
And the other example of digital governance that happening in Bali, like Bali has also a Bali Digital Hub, regional innovation center fostering digital entrepreneurship, capacity building, technology adoption across public and private sector, Bali Media Center, an integrated government communication platform supporting transparency, public information, and citizen engagement. And One Data Bali, an open data platform to support evidence-based policy and planning by the government. And also, the new policy is about Law Bali application, a digital tourism and cultural promotion platform integrating service delivery with cultural and preservation sustainable visitor management. So the conceptual contributions that related to Bali is the central conceptual is a culturally grounded integration platform that extends beyond conventional digital governance model, where mainstream literature proceed the relationship between technology governance. The study introduced local culture values as a third co-equal pillars. Conclusion: technology is necessary but not sufficient. Digital tools create infrastructure for monetization, but without governance aligned cultural grounding, they fail to deliver durable public value. Governance and trust are foundational. Institutional capacity, public participation, citizen trust must be deliberately cultivated alongside, not after, technology deployment. Local value are the strategic asset as need to be maintained continuously. So for policymakers, researchers, the development digital governance in subnational regions demands integrative frameworks that honor local institutional heritage while embracing technological innovation. I think that's it. Thank you.
Thank you so much for your presentation. So, any of the session chairs have questions for her?
Yes, yes. Thank you, Yashita. First of all, thank you for the presentation, ma'am. I have one question. Do you think the strategies implemented in Bali can also be adopted by other regions or countries? Why or why not?
Hello, Miss. I think it can be implemented in another region, but it has to be see the local values of the region itself. what is the, because now in the public service, how to achieve good quality service for the people. We need to we need to see what is the culture or the belief system of the people, so it makes it can be sustainable continuously in the future. For example, in Bali, we have a belief system they call Trihita Karana. So every modernization, globalization that comes to Bali, the Balinese people still protect their local values. They still care about the belief system. It's called the Trihita Karana. I think it can be adopted to another regions, but it must be recognized what the belief system, what is the culture that uh, uh, that implement or applied by the people continuously. It's like a belief system, something like that, I think.
Yes, yes. Thank you for elaborating on that point. I appreciate your insights. So I think that's all for me. Thank you and congratulations.
Okay, thank you. Dr. Rao, do you have anything to say?
No, it's okay. We can
Okay,
do the next person.
sure. So we have Ayman Chekira. Are you there, Ayman? Let me check once.
Yes, I'm here.
Okay,
Do you hear
yes.
me?
So, Ayman is here with us to present his paper titled as Mapping Global Research on Blockchain and Supply Chain Management Performance, a scientometric review. So, Ayman, you can start sharing your screen.
Okay.
Yeah.
It's is visible?
Yes, it's visible. You can start.
Okay, thank you. So, hello everyone. My name is Ayman Shakira, a PhD student and researcher at the National School of Business and Management, TIBS, Morocco. So today I'm honored to present our research entitled Mapping Global Research on Blockchain in Supply Chain Management Performance, a Scientometric Review. So this research was conducted under the supervision of my professor, Mr. Aziz Hamivi, and the objective of this study is to provide a comprehensive overview of the scientific literature linking blockchain technology and supply chain management performance, while identifying the main research trends, thematic structures, and intellectual foundation of the field. So, as a plan, this presentation will be organized into 6 main sections. So first, I will introduce the topic and explain its relevance. Then I will present the research problem and also the methodology adopted. After that, I will discuss the main finding obtained from the descriptive and content analysis. After that, I will present the limitations of this work, and finally, we'll conclude by highlighting the key contributions and future research opportunities. Yes. So, supply chains today operate in highly dynamic and uncertain environments. Organizations face increasing challenges related to transparency, traceability, coordination, and performance management. In response to these challenges, blockchain technology has emerged as one of the most promising digital innovations. Its decentralized and immutable architecture allows organizations to securely share information, improve trust among supply chain partners, and enhance visibility through the entire supply chain network. Consequently, blockchain has attracted considerable attention from both researchers and practitioners. Given this growing interest, it becomes important to understand how research in this area has evolved and what major themes currently characterize the field. So, for this reason, our study aims to map the intellectual structure, the thematic evolution, and research trends related, of course, to blockchain and supply chain management performance through this scientometric review. So, for the main problem and or question that we are trying to answer is what are the dominant research, as I said, themes, intellectual structure, and knowledge trends in blockchain related supply chain management performance research. For the methodology adopted, we adopted the scientometric approach. So the Scopus database was selected because of its extensive coverage of high quality academic publications and its compatibility with bibliometric software. A comprehensive search query was developed to identify publications related to blockchain technology and supply chain performance. So the search strategy combined blockchain-related concepts with performance-oriented supply chain terms. For this analysis, we use two complementary tools. First, WShiny for descriptive analysis and performance indicators, and secondly, the VOS viewer software for science mapping and keyword co-occurrence analysis. The initial search returned 711 documents. So several screening stages were then applied. For example, only peer-reviewed journal articles written in English were retained. This is for inclusion criteria. The analysis was restricted to studies related to management and supply chain management field. Conference papers, review articles, and purely technical or engineering-focused studies were excluded. After manually reviewing titles and abstract to ensure relevance, the final data set consists of 145 peer-reviewed publications published between 2019 and 2026. So this is data sets that form the basis of our scientometric analysis. So let us now move to the results. So the slide presents the evolution of scientific production and citation impact over time. So the results show a steady increase in publication between 2021 and 2025, indicating growing academic interest in blockchain applications within supply chain management. As we see, the highest publication volume was observed in 2025. At the same time, average citations per article show a declining trend. However, this decline should not be interpreted negatively because recent publications have had less time to accumulate citations. Overall, the field remains highly dynamic and demonstrates a strong academic impact. So the slide illustrates the geographical distribution of research activities. So the results reveal a relatively high international collaboration rate exceeding 45%. This indicates that blockchain and supply chain research is characterized by strong cross-border cooperation. So China emerges as the most productive country, followed by contributions from several countries in Asia, Europe, and North America. In contrast, Africa and many South American countries remain underrepresented. So this finding suggests opportunities for greater geographical diversification and increased international collaboration in future research. We now move to the content analysis. So the keyword co-occurrence network reveals two major thematic clusters. The first one, which is in red, focuses on blockchain adoption and supply chain performance. So keywords such as blockchain, supply chain management, performance, supply chain performance, and also technology adoption occupy central positions within this cluster. Research in this stream investigates how blockchain adoption contributes to operational efficiency, collaboration, competitiveness, and overall organizational performance. Technology adoption also appears as an important theme because many studies examine the factors that facilitate or hinder blockchain implementation. Overall, this cluster reflects a performance-oriented perspective in which blockchain is viewed as a strategic enabler of supply chain improvements. The second cluster focuses on transparency, traceability, and sustainable development. So this cluster indicates keyword such as I say, transparency, decision-making, sustainable development, and traceability. So research within the stream highlights blockchain capacity to improve visibility and information integrity across supply chain networks. By providing reliable and real-time information, blockchain supports better managerial decision-making and strengthens trust among stakeholders. So many studies also associate blockchain with sustainability objectives because greater transparency and traceability can
Ahmed,
contribute to more.
a quick
Yes.
reminder for you that you'll have to wrap up in 1 minute.
Okay.
Yes.
Uh, as I said, this cluster demonstrates that blockchain is increasingly viewed not only as technological innovation, but also as a governance and sustainability tool. So for the limitations of this work, mainly like any scientometric study, there are a lot of limitations. For example, the analysis relies exclusively on the Scopus database, which may exclude relevant studies indexed elsewhere. Second, only English language journal articles were considered, and the finding depend on the selected search strategy and screening criteria. And future studies should expand data sources, investigate blockchain integration with other emerging technologies, such as artificial intelligence and big data analytics. And also, we should conduct more empirical studies, specifically in developing and underrepresented regions. So to conclude this presentation, this scientometric review provides a structured overview of blockchain research in supply chain management performance. So two major thematic dimensions dominate the literature. First, blockchain adoption, supply chain performance. Second, transparency, traceability, and decision making, and also sustainable development. In addition, our analysis highlights important research trends, international collaboration patterns, and the intellectual structure of the field. We hope that this finding will support future researchers and practitioners interested in leveraging blockchain to improve supply chain performance. Thank you very much for your attention.
Okay, so I'm so So you said that Scopus database. How did you get access to the Scopus database?
Sorry, sir. How did I?
How did you
I didn't.
access Scopus database?
The access. So our university gives us the access to the Scopus via collaboration with this.
Okay. So did you
Yes.
design your local database for that one while copying? Definitely they might have given you the test data only. Did you design your own schema and database design in your local?
Design, you mean like a schema for the procedure of the
Yes, yes.
methodology?
Yes.
I did it for a systematic review, not here, not for Wmetric. I didn't actually.
So
I
in the
don't
case,
have a schema.
did you use any NoSQL data structure?
SQL, no. It was just manually screening, and
Okay.
yeah, I didn't use any programming language actually.
Okay, got it. Yeah. Okay, thank you. I'm done.
Thank you.
Okay. Thank you, Najera ma'am.
Thank you, ma'am. First of all, thank you, sir, for the insightful presentation. Based
Yes,
on your
thank you.
view, what are the biggest challenges organizations face when adopting blockchain in supply chain management?
Yes, so actually, my thesis is uh, I'm working on the context of Morocco, of our country. So actually, unfortunately, the biggest, even the biggest industries here in Morocco does not apply uh, blockchain yet. So there are a lot of problems, a lot of barriers that stop this adoption. We have financial problems. We have the the personal uh, struggles that this uh, this uh, this uh, what do I say? This technologies like they don't want to change their behaviors and the method of or manner of this of their work. So we don't have a clear clear idea to answer
Mhm.
this
Yes,
for
yes, it's
now.
okay.
Yes.
Yeah, thank you for your response. I appreciate the clarification and additional insights you provided. I think that's all
Yes.
for me.
Thank you.
Thank you and congratulations.
Thank you. Thank you.
Okay, thank you so much for your presentation. So for today's last presentation, we have Puttu Putri Pravitsari to present her paper titled as When Algorithms Meet Auditing, Unmasking Fraud Hexagon Schemes in the Digital Era. So, ma'am, are you present?
Yes, I'm already here.
Yes.
Can I start the
So,
presentations now?
yes, you can share your screen and start presenting.
Okay, I will share my presentations. Oh, wait a moment. Oh, wait. Oh, boleh berhenti bentar. Nggak bisa share screen-nya. System share.
Are you able to solve the issue?
Wait, I have a trouble on the share screen. Can I move to another device?
Yeah, sure. Can you do it a little fast, please? Like
Okay, okay.
input.
Wait.
Yeah, that's fine. You can. Have you joined from another device, or you're still on the same
Yes,
one?
already. Wait a moment. I changed with my phone. Wait.
Yes.
Can you help me to show my presentations, maybe? Do you have an email or
Yes.
something?
Okay, sure. Wait a
Can
minute.
you chat me for your email? I'm sorry.
I am putting my email in the chat box. Please check.
Okay. I'm not yet received it.
Yeah, wait 1 second.
Didn't-
Yes, it is in the chat box.
okay, wait. Uh, okay, I already sent it by emails. Can you check it?
Yes, 1 second. I'll be sharing my screen.
Okay, thank you for your help.
That's totally fine. Now you have less time to present.
Okay, it's okay.
Yeah, wait 1 second. Yes, you can start your presentation. I've
Okay.
shared this. Yes. Just
Okay.
tell me when to move on the next page.
Okay, thank you,
Yeah.
Yasita, for your help.
Yes, that's fine. Yes, you can.
Okay. Okay, what time I will have for
No,
presentations?
you have 10 minutes. You can wrap it up in 10 minutes. Don't worry
Okay.
about that. You concentrate on your presentation.
Okay. Thank you, Yasita, for your help. And
Yes.
also, yes, good evening for all participants and all of the member here. I'm sorry if I have trouble before. So I will start the presentations. My paper title is When Algorithms Meet Auditing Unmasked Fraud Hexagon Schemes in the Digital Era. So I represent my groups to represent my paper. Okay, next slide. Next slide. Before, yes, I'm from Universitas Pendidikan Nasional, so I will start from the introductions. When the digital auditing landscape now is advancement has transformed the financial reporting and also auditing. A lot of organizations rely on digital system generating fast financial data, creating both the efficiency opportunities and sophisticated fraud risk. And some of the phenomena today that digital auditing is more rise, like big data analytics, AI, and machine learning now enhance auditing efficiency, accuracy, and risk assessment. And also, we now have the government's gap that make weak governance, ineffective internal controls, and managerial incentives continue to drive fraudulent reporting. And also about the computer assistant audit tools enable analysis a large data sets with Benford law identifies potential data manipulations. Next. So this is from the abstract. Overall, this paper will talk about the financial statement are vital for conveying a company performance and health, yet fraudulent financial reporting remains a significant global concern, especially I involved with the fraud hexagon schemes, which is there are 6 schemes in fraud detections. Next. Next. So this is my research gap and novelty research. From the previous study that fraud hexagon is only focused on behavior drivers. But in my research, I integrate fraud hexagon with AI, machine learning, big data, and also blockchains that somehow the previous research only talk about the lack of the behavioral fraud framework. But in this paper, I combine with technology linked to 6 dimensions that called fraud hexagons. And some of the novelty in this research contributes the literature by proposing an integrated framework that combines the fraud hexagon theory with emerging digital technologies, including artificial intelligence, machine learning, big data analytics, blockchains, and charts. Unlike the prior studies that examine only behavioral fraud factors or technology tools separately, this study will synthesize both perspectives. So I combine both of these perspectives to provide a holistic technologies. Next. Okay, next. So this is the fraud hexagon framework. I have 6 fraud hexagon framework like pressure, opportunity, rationalizations, capabilities, arrogance, and collusions. Next. And this is the research urgency. We have some of the research urgency, like you can see on the screens, like financial statement fraud will remain a major global concern that threatening the transparency, stakeholder trust, and also organizational stability. In the figure that you can see, the first outer tech integrations like AI, machine learning, big data, blockchains, and also chats will combine with the framework. And the middle, I combine also with the behavioral accountings like fraud hexagon, pressure, opportunity, rationalizations, capability, arrogance, and collusions as the primary primary reasons that someone used to have the frauds. And also the core of the research urgency is I combine with need integrations between technology and also enable fraud detections. Okay, next. In this paper, I use the methodology is Prisma literature review that you can see on the screen. First one is identifications step, and then the screening step, and then the last one is included step. So this is the details of the features. And I use 109 studies that focus on the chat specifically. This research is dominated by the US, Canada, UK, Australia, India, Singapore, and also China that also have the strong global interest with AI or machine learning from the fraud detections. Next. And this is the overall from the result and discussions. The fraud hexagon and technology integrations provide a more comprehensive approach to detecting fraud financial reporting, and also AI, machine learning, big data analytics, and chat significantly improve the auditor ability to identify the anomalies and suspicious transactions. And digitalizations now is more perspective and more importance than the traditional audit. Okay, next. And this is the key finding that I can see from the several of the studies, like a holistic approach that integrates the emerging technologies with the fraud hexagon framework and strong governance mechanism is essential to improve audit quality and combat the fraud in the digital era. Next. Okay, next. And how blockchain technology for fraud preventions. Why blockchain works? The blockchains have the decentralized, transparent, and also immutable the nature of ensure financial transactions and cannot be easily altered, enhancing accountability and also reduce the fraud risk. And when combined with strong internal controls and digital competencies, blockchain significantly improve the financial reporting reliabilities and also enhance the traceability in transaction system. So now in real world, we have AI applications like real-time transactions monitoring at scale, network analyze revealing collision patterns, and also immutable audit trails while preventing data tampering. Next. And this is the impact of digitalizations on auditing process, which is we have a technological competence, fraud accounting, let's cloud computing, data mining, and also AI enhanced auditors have capabilities in detecting complex fraud scheme. So this is a really organization's research that we have to know that we have a challenge that remain like regulatory uncertainties, technological complexity, skill gaps, and also the black box nature of AI raise the transparency concern. Next. So we have to compare the technology approach by holistic review, while the technology alone cannot combat the fraud effectively. So we have to integrate both of the technology, corporate governance, forensic accounting, and also preventing accounting is also essentials problem now. Next. So from all further research, I have the conclusions that we have a multi-phases approach to fraud, like in technology perspective, like AI, machine learning, analytical, blockchains, and also RPA. And also we have to combine with the good governance. We have to good audit commutes, ethics and internal forensic accounting controls, and also collaborations, both of the internal and also external auditors, stakeholders, and also investigations. So if we only have one perspective, only technology perspective, we will have no we will not have the effective audit, but we also have the three combines, both of the technology, governance, and also collaborations. So I think that all from my presentations. Thank you so much, Yasita, and also all of the participants. Thank you so much. The time is yours.
So what is the
Yes.
hexagon framework? Can you explain what is the hexagon framework? How did you integrate this blockchain technology?
Pardon me?
Hexagon framework. What is that? Come again. Show me that one. The first title, if you show me, then I can ask you again clearly.
Yeah, wait,
Show me the
one
title of
second.
yours.
Okay, maybe Yasita, can you help me to show us?
Go to the first slide. First slide or second slide. Good. Yes, hold on. Hexagon schemes, right? Asking fraud hexagon schemes. So that fraud, you have categorized them as hexagon schemes. Can you explain how did you do that one? What is in the
Uh,
hexagon schemes here?
which games do you mean?
Unmasking fraud hexagon schemes in the digital era. That means that already fraud is there, which is in hexagon schemes. What is the hexagon here?
Yasita, can you help me to show the fraud hexagon schemes? Maybe in the next slide.
Yeah. So,
Yeah. So this is the fraud hexagon framework.
okay, got it. Yeah. Mm.
So we have the six fraud hexagon frameworks. Is the integrations. This is the comprehensive framework for understanding the fraudulent behavior while auditor why they have to be making a fraud. So there are six reasons why the auditor make the frauds, like pressure, opportunities, rationalizations, capability, arrogance, and also collusion. So I combine these schemes with the technologies.
Okay, got it. Yeah.
Okay, thank you for your questions.
Okay, Najira ma'am, do you have any questions for her?
Thank you, Yashita. First of all, thank you for your presentation, ma'am. It was actually comprehensive and easy to follow. I don't have any questions at this time. Thank you for sharing your research and congratulations.
Okay, thank you, Mrs. Najira, for your feedback and your times.
Thank you so much for your presentation.
Thank you, Asita, for your help.
Thank you. Thank you. So, as we have come to the end of this session, I will sincerely thank all our authors for their excellent presentations and valuable contributions, and all the participants for being an important part of this international conference. I truly hope that this session was very insightful and engaging for everyone. On behalf of the entire team, we thank you for your continued support, not just for this edition but all the previous editions of TIBS. We look forward to welcoming you again in the next version in 2027 as well. So, all presenters will be receiving their digital certificates via email within 2 working days, and the publication will get live within 7 to 8 months. So, we kindly request your cooperation with the TIBS 2026 team. I would also like to extend my sincere thanks to both our session chairs, Najera ma'am and Purna Chandra sir. Thank you for expertly chairing this session. So, this is a small token of appreciation on behalf of the TIBS 2026 team and Global Knowledge Research Foundation and partners. So, thank you so much for joining us today. And thank you once again for all of you for your valuable presence. So, before we officially wrap this up, let's quickly capture this as a memory. I kindly request everyone to please switch on their cameras to take a group snapshot. So I will quickly take a snapshot. 1 second. I request everybody to please turn on their cameras. Yeah. Okay, thank you so much for joining, everybody. Stay safe. Take care, everyone.
Thank
Thank
you.
you.
Yes.
Thank you so much.
Thank you so much.